Okay, so we're starting now. 9-1, simplifying and combining radicals. For my group of students from Math 1033, sections 008, 037, 047, this is the lecture corresponding to November 4th. I'm going to divide this into two parts, between the two of them, adding up to 50 minutes or less. We're not going to go beyond that. That means if we don't finish 9-1, we'll continue next time I see you. Okay, so let's share the screen over here. They changed some of the ways to do this. And I don't know. Okay, here we go. Okay, so this is the same for my three sections, 008, 037, 047. So hopefully that's not an issue. My mouse is not working very well. So I want you to know that if you go to modules and you go to unit 9, come on, unit 9, you will have both sets of notes that I follow like we do in the classroom lately. Notes outline and notes by hand. I'm still going to write everything by hand here today. I'm going to use my iPad. I'm going to share my iPad. But you would have something like this. Come on, computer, let's do this. Let's show it. 9 more seconds, or we just download. Don't know why it does this. I'm just going to download that so you can find that. Okay, here we go. So you will have something like this. I leave space because I'm going to write some additional information on the iPad, so you'll see that. So the handout that I will print will be this. If you don't want to print it, you can just write everything. If you want to print it, but you don't have where to print it, you can also print it in my office. So you have those options. So in addition to the one that's the outline, I also have my notes by hand if you just want to listen and follow this. So we'll give this a few seconds as well, and you'll see the scanning. 9-1 is simplifying and combining radicals. So it's a topic that begins, pretty mild, but then some other problems later on are not trivial, okay? So hopefully this will open up soon. Otherwise, again, I'll show the download, and I apologize for the extra time that this is taking. Let me stop sharing here and then share instead the download, okay? The technology right now not working with me. The mouse is not working. The download is not working. Oh my goodness. I just want you to see this so you know that it's available. And we also know where to find it. So it will be like this. The notes by hand, which just fill in the blanks and so on of what we will be doing today, including some problems in the homework that I want to take a look at, okay? So there we stop sharing and we're going to move on to the iPad and Nikki. And then now again, you're welcome to use the handout or take your own notes, but you will have to submit something as I explained in the announcement. You can find this video or the link to this video. You have to submit some amount of notes to count for attendance. So I know that you watched this. You see a cat back there. I know that you watched this before we move on to section 9.2. Okay, so now let's share the iPad and let's begin the actual lesson. Okay, all right. So simplifying and combining radicals. A radical, also known as a root. And again, you can use a handout or take your own notes, but the handout has a lot of this information or some space available to write down this information. This is a mathematical inverse of an exponent. Okay. The mathematical inverse of an exponent. And we'll see some examples. And if you look at that handout, you'll see that this is not there. So I left some space. This is where we would write it. Examples of radicals that we've seen before. Square root of 4, which we may know at this point that is equal to 2. Another example is the cube root, okay? Let me see if we talk about that one in particular soon. Sorry, give me 1 second. Trying to see here, we do. Trying to make sure that I include everything that I wanted here. Let's see that I don't have. I don't have a place, and this is my bad, where I call, for example, we have square root, we have cube root, and then we have fourth root or things like that. So I would have to write that down later in additional notes because I did not include that. Okay. So just want to check that. Oh, I do have it. My bad. It's in the it's there. So if I'm looking for the cube root of 125, we would write it like this. Then we'll practice this. We'll practice this step by step. But these are just examples of these radicals, also known as roots. And this in this case will be what number multiplied by itself 3 times will give me 125. And another example of a root would be, let's say that we have 256 times x to the power of 4, and we're looking for the fourth root of this, which would be 4x, and we will learn how to do that today. Okay, so these are examples of radicals or of roots, and again, my notes are posted online if you prefer to take a look at that, but remember that you have to post some notes. So we're going to start with square roots. Square roots. And the square root of a number r, let's call it r, is the number t maybe it's easier with numbers instead of variables, such that t squared is equal to r. So the square root of r, the square root of r is the number t, such that here we're used to this notation, square root of r is equal to t, or if I square both sides, I get t squared equal to r, okay? Okay, an example of this, we have numbers instead of variables. We have the square root of 9 is equal to 3, where r would be 9. Square root of r is a number t, in this case would be 3. It means that 3 squared, or 3 multiplied by itself, okay, will be equal to 9. So this one we are more used to, so we're not going to practice too much, but there is something that we need to know here. When asked for a square root, for a square root, always give the positive value. I do know that -3 times -3 is also equal to 9 when I'm looking for the radical, okay, when I have this symbol for the radical, and I'm looking for the square root of 9, I will give the positive root, okay? So always give the positive root. Okay, so this might be a review for some of you. Now let's take a look at other roots when I don't have square root, if I have cube root or fourth root and so on. If I knew how to edit videos, I would edit that part out, okay? All right, the nth root, where n can be another number that's not 2, or it could even be 2 as well. The nth root of a number, let's call it s, is the number p such that I miss it to make sure I stay under 15 minutes total. So the nth root of a number s is the number p. So I'm looking at the square, not the square root, the nth root of a number s is the number p, such that p to the power of n is equal to s. Okay, and we'll see an example. Actually, I don't have an example in my notes, so let's add an example here. If I'm looking for the cube root of 8, for example, then I'm looking for a number that's elevated to the power of 3 is equal to 8. Therefore, I'm looking for a number that multiplied by itself 3 times total will be equal to 8. And that number is equal to 2 in this example. This was not included in the notes because I was not planning on doing that. Now, notice that when I have an odd number, okay, then I can have a negative for S, okay? Let's go one thing at a time, and for this we follow the notes. If S is greater than 0, so this number here, if this is greater than 0, so it's a positive number, then P will be greater than 0 as well, right? Regardless of what N is. So if that number is positive, then if S, then P will be positive. However, if S is negative, then if I have a cubic root, for example, or cube root, the number will be a negative number, right? You don't have to write this one down, so I'm going to do a different color. If I'm looking for the one I just said, but negative, then I know that negative 2 times negative 2 times negative 2 is equal to negative 8. However, if I'm looking for the square root, when n is an odd number, could be 2 as well, then this does not exist. No number multiplied by itself will give me a negative number, okay? So sometimes I know I am erasing this, so you're welcome to go back and take a look at that. But just wanted to make sense with numbers instead of this greater than 0, less than 0, and so on. So if this number that's highlighted up there, S, is negative, then if my bad. Then if N is odd, such as 1, 3, 5, and so on, then P will be negative. But if N is even, your value does not exist, okay? If you have questions with this, because without an example, just writing this greater than 0, less than 0, and so on, might be confusing. So if you have more questions before we take a look at the next 4 examples, please let me know, okay? So some examples. Again, need to stay within the 50 minutes. Negative square root of 64. Notice the negative is outside of your radical, so I have negative whatever the square root of 64 is. Square root of 64, we're looking for a number that multiplied by itself. That number times that number will be equal to 64, which is equal to 8. Okay, so I have the negative outside of my radical, so I'm not looking for square root of that negative, right? For B, I'm looking for the square root of negative 49, which is this case over here. Notice that I have the value inside of my radical is negative, and then N is even. So we do know, why are you going away? We do know that no number multiplied by itself will give me negative 49. Also, you guys gotta see this. I have company. You guys see that. All right. No number multiplied by itself will be negative 49. So here we would have does not exist. Okay. Apologies for that. Does not exist. All right. Example C. I'm looking for the 4th root of 16. So this will be equal to a number P. Let's call it P, but you can call it whatever you want. So I'm saying that P times P times P times P is equal to 16. P multiplied by itself 4 times. And this, you could do with a calculator or you can start guessing, will be equal to 2. 2 times 2, 4 times 2, 8 times 2, 16. Last example, I'm looking for the cube root of negative 64. So I'm looking for a number multiplied by itself 3 times will be equal to negative 64. And I'm going to scroll up, my apologies. This is one of the examples where n is odd, okay? I keep scrolling. So n is odd up here. We have equal to 3. And we have that s is negative. So this can exist because if I have negative 4 times negative 4 times negative 4, yes, the first two negative 4s multiply up to 16. Then times negative 4, this will be equal to negative 64. Therefore, the solution is negative 4. Okay. Ooh, the next part. I remember not liking it when I reviewed it, so maybe you'll like it more. Maybe you'll be better at it than me. Conversion between, and yes, there's no pause, so the pause will be created by yourself as you're watching. Conversion between radical notation and rational exponents. I feel like they pick the words in a way that makes it harder for us to understand. Radical notation, my bad. Not just you, me as well. Conversion between radical notation, which is what we just learned, square root or nth root, and rational exponents. Rational exponents, it means an exponent where I have a fraction, okay? So x to the power of 1/2, for example, okay? All right, so bear with me here. This will be my rational notation. If I have, and we'll see examples with numbers, a to the power of m, the nth root of that, okay? This is equal to a still to the power of m divided by n, all right? In my notes, I included more. Let me see if I should write this down here. This is the conversion from radical notation to rational exponent. But I do want to add something else here, which I don't know if you have seen before or not. This is also equal to, this is still radical notation, the nth root of a, all of that, to the power of m. Okay, so I want you to have that information, and that is on my notes. But this over here is the one that we're supposed to learn at this time, okay? Let's look at an example of this. If I have 4 to the power of 3/2, so I have rational exponent, and I want to change that to radical notation, and I follow what is highlighted, where this is 4 to the power of 3/2, then that can also be 4 to the power of 3 square root. Notice how I took, can I highlight different? No, different color here. And we'll see this slowly soon. This 3 will be equal to m, so m stays here. Okay, and then you're not working with me, computer. Thank you. And then here I have n, which is equal to 2 for this example, and that becomes the index of the radical, which if it's just 2, we don't write it. Okay, let's see that step by step instead of having that highlighting, and let's call those terms. Let's call each one something instead of saying m and n and so on. Okay, so back to this one, not that one. There we go. Oh my goodness, my cats. Okay, so I have a m to the power, sorry, a to the power of m, the nth root of that. A is called a radicand, okay? M is the exponent of the radicand. I don't want you to memorize any of this at this time, okay? When you're working on your assessment, on your quizzes, and you don't remember the names, just ask me, okay? It's not my intention that you memorize this at this time. N is the index of the radical. The radical is the entire term. So the index of the radical. M, the exponent of A, and A is the radicand, okay? So how can I make this like, okay. To make sure that we're following this here, the steps that we take, okay, and this is in one of the multiple choice questions, the index of the radical, which is N, notice up here, okay, take a look at this. The index of the radical becomes the denominator of the exponent. See it right here, the N, okay? Let's write that down. The index of the radical, and this is what I'm saying, that we don't want to memorize any of this. We just want to make sure it makes sense. If you're looking at the notes, that it makes sense. So the index of the radical becomes, before I write it down in a mathy way, becomes the bottom, right? Becomes the bottom of the exponent of A. So it becomes the denominator of the rational exponent. Roger. Of the rational exponent. So we took care of N. Now let's also take care of M, okay? The exponent of the radicand, not radical. So now M, if we compare what's highlighted up there, becomes the numerator of the radical exponent. There's so much going on here, right? The exponent, so M, the exponent of the radicand, so the exponent of A becomes the numerator. This is just a math way, or the mathy way to explain words what is happening. I'm going to scroll what I highlighted up there. Okay, M becomes the numerator, N becomes the denominator when I want to change it from radical notation to rational exponent. The exponent of the radicand becomes the numerator of the radical exponent. Pretty sure this is in one of those multiple choice questions on your test. So denominator here and numerator here, okay? We're almost done with part one, so that's good. That's good. That's part one. You can, I don't know what you can do. Just do part two, I guess. You can take a break. Examples, and for one of them, for example, A particularly, we will use the prime factorization tree. Not sure if you've done that before, okay? So here I want to turn this, so let me see. I didn't write on my notes exactly what I wanted you to do. I wanted to convert from a rational exponent to radical notation. Convert to radical notation. Thinking that after this example, this part one is over. Oh no, that's so great. Convert to radical notation. Okay, so I'm gonna scroll. We're gonna use that A to the power of mn, of m divided by n. I'm gonna apply it to this. So A is 12, that's great. A is 12. And then M is 2 and N is 3. Great. So I could do something like this. I'm not sure why I'm having sound effects over here. Okay. 12 to the power of 2, and that finding the cube root of that. However, we can keep going. If it's a test problem, you get up to here, you get 0 according to the computer, you get some partial credit from me, but we can keep going. See if we can simplify this. We want to simplify this so much that whatever we have inside of my radical, I cannot simplify anymore unless I start using decimals, okay? So this, from your calculator, is 144, the cube root of that. And here is when we use the prime factorization tree, which is something that we should have seen before, but if you have questions about this, please come to me. 144, I want to factor this as much as possible. We know this is 12 and 12. 12, we can use 3 and 4, or we can use 6 and 2. I'm just looking for factors that just cannot go any further. 2 and 2, 3 and 2, and 2. I'm not gonna go any further here. So it looks like, and this is the row that I'm going to use, all of those numbers multiply. This is 2 and 2, not 22, okay? So it means that 3 times 2 times 2 times 3 times 2 times 2, all of that is equal to 144. So if you want to follow this step, you can, or you include all of those factors here. 3 times 2 times 2 times 3 times 2 times 2. And notice that 3 is there only twice, so I can't say a number multiplied by itself 3 times, because that's my index. I can't get it out of my radical. However, 2 is 4 times. So I can get these 3, which are equal to 8. I can find the cube root of that. That 2 comes out. However, I still have left 3, 3, and 2, because I use 3 of these, right? But number multiplied by itself 3 times will be equal to what number? Number multiplied by itself 3 times the cube root of that. Okay. Then I have 2, and here I have in here 18, the cube root of that, and I cannot simplify that anymore. So we have to go that far in order to get all the points on the test. Okay, so here I'm looking for the prime factorization tree. If you have any questions on how to do that from past material, please let me know. Next, so the second part, we'll do examples B and C. You can see on your notes, just with numbers, and we have 4 more examples with variables. And then after that, we have combinations of radicals, multiplication and division mostly. And then we'll take a look, if we have time, at some examples from the homework, okay? I'm gonna close this like I'm done. I'm not done. I still have to report the second one. Thank you for watching. Stop sharing. Let's hear when I see myself. And then stop recording. We're here. Thank you.